fundamental circuits or tie set. So here in this case, again, this approach for the calculation of the currents by using this method, which is nothing but the fundamental circuits or tie set. This method is very similar to the KVL, that is Kirchhoff's voltage law. We can apply the KVL to the different loops, and we can prepare the loop equations, and we can find out the currents, and then we can find out the branch voltage and branch current. That kind of the approach is there. How is this approach? That I will discuss. Fundamental circuits or tie sets. For a given graph, first select a tree and remove all co-tree branches. There is nothing but link or cord. What is expected to begin with this particular method? To begin with this particular method, if the circuit is given to us, first convert that circuit into the standard format, and after that draw its oriented graph. And for oriented graph, first select a tree. How to select a tree? We have discussed it previously. Otherwise, I will discuss at the time of discussing this particular point. And remove all the co-tree branches. Means if we are selecting a tree and we are removing all the co-tree branches. Means here, the concept of the tree is a must in case of the tie sets and cut sets. Is it right? Then, as per the each link placed at a time. Link means this link or cord means co-tree branch. As each link is placed at a time, it will form the closed path, and this closed path is known as a tie set. You see how the tie sets are created, that we are trying to discuss. How the tie sets are created. Now here, the direction of the loop current is very same as the direction of the current on the link or co-tree branch. The direction of the co-tree branch, and the total number of the tie sets is equal to the total number of the co-tree branches. There is nothing but links or cords. This is not the off. Links or cords. This is right. So here, throughout this discussion, you might not have understood anything. But here, I will take one simple example. Through that example, we will try to understand what is the fundamental circuits or tie sets. Is it right? Now here, I will come to this figure. Listen carefully. And if you have any doubts, just raise your hand. I will clarify your doubt. First, I am trying to discuss about the fundamental circuits or only the tie sets. I am discussing about the tie sets. What are the tie sets? This is the graph which we have obtained for any figure or any circuit to be exact. This is directed graph. For this graph, first we will prepare a tree. This is step number one is a preparation of this. Step number one is a preparation of the oriented graph. This is the step number two, which is nothing but the preparation of the tree. If we are selected as a tree can be anything. Otherwise, sometimes in the examination they will give the tree and we have to find out well. Otherwise, you can select the tree of your choice. Is it right? What is the definition of the tree? It connects all the nodes to each other directly or indirectly without forming a loop. That is nothing but the tree. You see, in this case, we have the node A, node B, node C, and node D. All these nodes are connected to each other directly or indirectly without forming a loop. Means there is no formation of the loop. Is it right? And what is the what are the number of tree branches? Number of tree branches are n minus 1. That is, n is nothing but number of nodes. You see, in this particular case, 1, 2, 3, 4, we have the 4 nodes. 4 minus 1 is equal to 3. This we will have the 3 tree branches. Is it right? Then, now what are the number of tie sets, or what is the tie set? Now here, in this case, this is the branch number 1, branch number 4, and branch number 6. These 3 branches are the co-tree branches. Are you getting me? These 3 branches are the co-tree branches. Now what we are doing, we are placing one co-tree branch at a time. We are placing one co-tree branch at a time. In that case, suppose for example, I am putting this co-tree branch number 1 here. If I am putting that co-tree branch number 1 here, this is the branch number 1. Now look at it. There is the formation of the loop, and this loop is nothing but the tie set. This loop is nothing but tie set, which I have shown here in this particular figure. If we are placing this link number 2 or cord number 2 or co-tree branch number this 1, in that case it will form the loop, and this loop is nothing but the tie set, or it is also known as a fundamental circuit, but popular name is the tie set. Now this is the tie set. What is the tie set number 1? Tie set number 1 is it is 1, 2, 5 is the tie set number 1. Means what is the tie set? Tie set is a set of the branches in that particular loop. This triset number 1 is branch number 1, branch number branch number 1, branch number 2, and branch number 5 is triset 1. Similarly, in the same tree, if we are putting the branch number 6, if we are putting the branch number 6 in that particular case, something is like this. Is it right? Now this is again closed path. This closed path is known as another triset. This may be the triset number 2. Is it right? This may be the triset number 2. Now here in this case, this branch is branch number 6, and this is the triset number 2 is branch number 2, 3, 5, and 6. Branch number 2, branch number there is 3, branch number 5, and branch number 6. It forms a triset. Branch number 6 it forms as a triset, or it is closed path. But what should be the direction of the current of that particular loop? Generally, in case of the mesh analysis or in case of the KVL, we are assuming the random direction. But here there is no choice for assuming the random direction. We have to assume the direction as per the rules. What are the rules? Rules is that look at the direction of this co-tree branch. Look at this direction of the co-tree branch, and the loop current will be assumed which will suit to this particular co-tree branch. If it is upward, then it should be clockwise. Now, in this case, look at this co-tree branch. This is branch number 6. This current is towards left side. That's why this current of this particular loop will be taken as anti-clockwise. Finally, if we have this co-tree branch number 4, if we are putting this co-tree branch number 4 here, in that particular case, again it will form the closed loop. What is the triset number 3? Triset number 3 is 2, 4, 3, or 2, 3, 4 is the triset number 3. And what should be the direction of this triset? What should be the direction of the current in this triset? Triset is nothing but it is set of the branches forming a loop in that particular graph. It should be same as this 4. This is 4 is a forward, that's why its direction it must be clockwise direction. This should be the direction of current in this particular case, and these are nothing but the fundamental circuits or trisets. But don't try to mix up everything in the single figure. In that case, if we are putting this triset number 1, if we are putting this triset number 2, and if we are putting this is the triset number 3, then it is very difficult to understand which is the triset number 1, 2, and 3. That's why it is better to draw the separate figure for each triset. That is my recommendation. You see, always what I will do, I will suggest that for every triset you should draw the separate figure. The selected tree, put a branch. Then how many number of the trisets we have? The number of trisets is equal to the number of co-tree branch, because at a time we are putting one co-tree branch. This is co-tree branch number 1, this may be the co-tree branch number 2, and this may be the co-tree branch number 3. If we have the 3 co-tree branches, in this particular case, we should have the 3 trisets. Is it right? Because we are putting one co-tree branch at a time, and that is the philosophy of this fundamental circuits or trisets. If we have understood this concept, nothing is complicated in this particular case. It is very same as the reduced incidence matrix approach. I will come back to you. I will discuss few points and then I will discuss its next part. Yeah, I'm coming back to you. So here in this particular case, if we are aware of this concept, I will introduce you to the new approach that I will discuss here. This is the basic fundamental things. There is fundamental circuits or triset. Is it right? Now, we will try to understand the triset matrix. This triset matrix, try to understand this philosophy. Just like we have the reduced incidence matrix, in the similar way, we have this matrix which is known as the triset matrix. Are you getting me? This matrix is nothing but the triset matrix, that concept we have here. Now here, try to understand what is the triset matrix. Look at. Trisets represents the rows of the matrix. If it is a matrix, what are the rows of the matrix? This is triset number 1. I will call it as the T1, triset number 2, which is nothing but the T2, triset number 3, that is nothing but the T3. These are the rows of the matrix. How is the case in case of the reduced incidence matrix? The nodes are the rows of the matrix. But here in this case, the trisets are the rows of the matrix. Trisets are the rows of the matrix. tie set represents the rows of the matrix. In this particular figure, whatever we have discussed previously, for this particular figure, how many tie sets we have? We have 3 tie sets, 1, 2, 3. This we should have 3 rows for this particular matrix. Is it right? There is nothing but the tie set matrix. Then I will come back to you again. In this case again, the branches represent the column of the matrix. Branches represents the column of the matrix. These rows are nothing but the tie sets. And what are the columns? Columns are nothing but the branches of the matrix are not, branches of the graph are nothing but the column of the matrix. Here in this particular case, column of the matrix. If the branch is in the loop, that is nothing but the tie set, and its direction is the same as the loop current, then that entry will be taken as a +1 in the matrix. With 3 possibilities for the entries of that particular die set in the matrix are 3. There is +1, maybe -1, or maybe 0. Look at how are the entries. If the branch is in the loop and its direction is the same as the loop current, then its entry is taken as +1 in the matrix. Right? And if branch is in the loop and its direction is opposite to that of the loop current of that particular tie set, then its entry is taken as -1 in the matrix. Is it right? And finally, if that branch is not in the loop, then its entry will be taken as 0. That is the philosophy of the preparation of the tie set matrix. Believe me, it is very, very simple. I will discuss with example. This is the example. Is it right? Now here in this case, this is graph. This is given graph. For this graph, we are selecting as a tree. This is tree, which we have selected. It has a tree. This is tree. This is tree. For this tree, first we will prepare the tie sets. First we will prepare the tie set. Means first I will put this co-tree branch, which is 1. In that case, branch number 1, branch number 2, and branch number 5. This is the tie set number 1. Here I will put here. This is the tie set number 1 because rows of the matrix are nothing but the tie set. If we are putting this branch number 6, sequence may be anything. First we can put 1, then you can put 4 and 6, or maybe the reverse, or maybe you may start with the 6, or whatever it may be. This is 6. If we are putting the 6, then again it will form the closure path. This closure path is nothing but the tie set number 2. I will call it as a T2. This is the second row. And if we are putting this branch number 3rd, in that case it will form the 3rd closed loop, and that is nothing but the tie set number 3. In this case, we have the 3 tie set. That's why we will have 3 rows. Now, how many columns we will have? We will have 6 columns because 1, 2, 3, 4, 5, 6. The columns is equal to number of branches. We have the 6 branches. This is branch number 1. This is the branch number 2. This is the branch number 3. It is the branch number 4. This is the branch number 5. And finally, it is the branch number 6. We have, these are the 6 branches. 6 columns. Are you getting me? Now look at how will be the entries. It is very, very simple. In this case, if we are taking the entries, how are the entries? Now look at. The direction of this co-tree branch is upward. That's why the current in this particular loop is taken as a clockwise. This current is not taken it as a random. This current is taken as per the direction of the current of this co-tree branch. Is it right? Now look at it. As per this co-tree branch direction, this branch number 1 and this co-tree branch current is the same. Our loop current has the same direction. That's why its entry is a +1. For branch number 2, it is downward and this loop current is also downward. That's why its entry is a +1 again. For the branch number 5, its direction and this loop current direction is the same. That's why its entry is again +1. And the remaining branches, that is branch number 3, branch number 4, and branch number 6, these branches are not the part of this particular loop. That's why those entries will be 0. Is it right? Similarly, in this particular case, this is the tie set number 2. This is the tie set number 2. In this case, the direction of this co-tree branch is towards left. That's why this loop current direction will be anti-clockwise. And with this direction, look at the branch number 1. Branch number 1 is here, which is not the part of this loop. That's why its entry is 0. Branch number 2, its direction is a downward, and this loop current is also matching to that particular direction. That's why its entry is +1. Similarly, for the branch number 3, its entry is suiting to that branch current. That's why its entry is again +1, because this tie-set current or loop current is same as this branch current direction. That's why its entry is +1. This branch number 4, where is the branch number 4? This is the branch number 4, which is here. That branch is not part of this particular loop. That's why its entry will be 0. Look at the branch number 5. Branch number 5, its direction is towards right. And this loop current or this tie-set current is suiting to this particular current. That's why again the branch number 5, its entry will be +5. And finally, this branch number 6. This branch number 6, its direction is shooting to the direction of this particular loop current, this loop current or this particular tie-set current. That's why again its entry is +1. This is the preparation of the second row of this particular matrix, which is known as a fundamental tie-set matrix. Fundamental tie-set matrix. We have only the 3 matrices in this particular case. Major role of the 3 matrices is there. In the first case, we have discussed about the reduced incidence matrix. Second is the tie-set matrix, and third is the cut-set matrix. That is the philosophy about this complete network topology. If here I'm coming back to this loop number 3 or this tie-set number 3, look at this is the co-tree branch. That's why the loop current in this particular case is the same as that co-tree branch. Is it right? Now, if we are preparing this row number 3, which is related to the tie-set number 3, look at the entry for the branch number 1. It is 0, because that branch is not the part of this particular tie-set. That branch is not the part of this particular tie-set. Is it right? Okay. Then next is the branch number 2. Branch number 2, its direction and this direction of this loop current are opposite, because it is downward. And if I'm taking this as loop, its direction is coming to be upward. That's why that entry is -1. For branch number 3, again, loop current is downward, this branch current is upward, that's why its entry is again -1. For branch number 4, its direction is same as this loop current direction, that's why its entry is +1. And branch number 5 and branch number 6, which is this is the branch number 5 and branch number 6. This is branch number 5 and this is the branch number 6. These 2 branches are not the part of that particular loop, that's why its entry is 0. This is the formation of a fundamental tie-set matrix. This is the given figure. For this particular figure, we want to prepare the fundamental tie-set matrix. We are interested in the preparation of the fundamental tie-set matrix. Yes. Yeah. I'm coming back here. So here, how is the procedure which I have discussed previously? How is the procedure for the preparation of this fundamental tie-set matrix? First, we have to prepare its graph. Again here in this case, in case of this fundamental tie-set matrix, in case of the tie-sets to be exact, all the sources must be in terms of the voltage sources, just like we have in the previous case, all the sources must be the current sources. Is it right? And all the branches must be in terms of the impedances, and that I will discuss later on. That's why I will copy this figure as it is. No correction is required for this particular figure. First I am trying to draw its graph. Look at how is its graph. Is it right? In this case, first what I will do, I will give the number of branches, number to the branches and nodes. This may be the node A, this is the node B, this may be the node C, and this will be the node D. Is it right? I will name this branch as a branch number 1. This may be the branch number 2. This may be the branch number 3. It may be the branch number 4. This may be the branch number 5, and this is the branch number 6. Are you getting me? First branch, second branch, third branch, fourth branch, fifth branch, and sixth. Name can be anything. You can give you in a different way also. No issues. At the same time, I'm assuming it's current upward. This is downward. This current is again downward. This current is downward. This current is downward, and this particular current is backward in this particular way. I'm assuming the currents. Is it right? This is upward, downward, downward. There is no philosophy or there is no logic behind assumption of the current. You can assume any current randomly. Is it right? Then I will take this as its fourth node. I will name the nodes. In this particular case, I will draw its graph first, oriented graph. This is the node A, this is the node B, this is the node C, and here it is the node D. We have the four nodes. Is it right? Only the sources are replaced by its internal resistance. Whenever voltage source is there, replace it by zero resistance, and if current source is there, replace it by infinite resistance. Are you getting me? Replace it by the infinite resistance. Is it right? Now here in this case, this is the branch number 1. Is it right? This is the branch number 2. Here is the branch number 3. Is it right? This is the branch number 4. I'm connecting the branches. Just each element is replaced by single line. This is the branch number 5. And finally, this is the branch number 6. This is the graph for this particular matrix. Now look at how is the direction. This is the branch number 1 having upward direction. This is the branch number 2 having downward direction. This is the branch number 3 having the downward direction. This is the branch number 4. This is the branch number 4 having its current towards left. Then we have this branch is the branch number 5 having its direction towards downward. And this is the branch number 6. This is the branch number 6 having its direction downward. Something like this. This is the graph. Is it right? If we have the graph, we are interested in preparing the fundamental tie-set or fundamental circuit matrix or tie-set matrix. Means first we have to select a tree. What is the first point? First point is the preparation of the oriented graph. Oriented graph. Then second point is selection of a tree. Selection of tree. Generally, the selection of tree is given by the examiner in the examination. Because if we have the different tree, we will have different answers. But the final branch currents and branch voltages will be the same. Is it right? Because if we are selecting a tree is a different, means loop will be different. If we have the different loops, loop currents will be the different. But finally the branch currents will be the same. Is it right? Selection of a tree. I will select a tree. What is the philosophy of the tree? Tree is nothing but it is a set of the branches together with the nodes, which will connect all the nodes to each other directly or indirectly without forming a loop. If we have these are the four nodes, we will connect these nodes to each other directly or indirectly without forming a loop. Straight away, how many branches we will have for this particular tree? For this tree, number of branches formula is n minus 1, where n is the number of nodes. If we have 1, 2, 3, 4, 4 nodes, 4 minus 1 is nothing but 3, we will have 3 branches for this particular tree. Is it right? Here, the simple tree, if I am selecting, this is one branch, this is the second branch, and this is the third branch. Is it right? In this case, this is the branch number 2, this is the branch number 3, and this is the branch number 6. This is the simple tree which I have selected. The tree may be something like this. I will show some other possible combinations of the tree. I will show some other combinations of the tree. How will be the other combinations of the tree? Look at this. For the same graph, if it is node A, this is node B, this is the node C, and this is the node D. I can have branch 1, 2, and 3. This may be the another tree. You're getting me? This is the node A, this is B, this is C, and this is D. This may be the given, or we have to select this is as a tree. They will give some points. Assume the branch number 2, branch number 3, and branch number 6 as a tree, and find out its fundamental circuits and its tie-set matrix. In that way, the question will be there in the examination. Select branch number 1 for this given figure. Select branch number 1, branch number 2, and branch number 6 as a tree. Something this will be the tree. There are number of trees are there. Here it is A, this is B, this is C, and this is D. Means in this particular case, this may be the one branch, second branch, and third branch. Maybe something like this. This is another tree. Means this is A, B, C, and D. There are no many trees are there. Select any one tree first. First procedure or first point in this particular case is select any tree. If it is not given, if it is given, select the given tree. This is the tree. Now, for this particular tree, first prepare the tie sets. I am preparing the first tie set, that is tie set number 1. Die set number 1. If I am preparing the tie set number 1, how is the procedure for the preparation of the tie set? How is the procedure for the preparation of the tie set? The procedure for the preparation of the tie set is that first draw the tree as it is. Here, this is the branch number, this is the node number 1. This is node 1. Just I will take here. This is the node number 2. This is the node number 3. And this is the node number 4. Are you getting me? These are the 4 nodes we have. I will give the names to these nodes. This is A node. This is B node. And this node is the C node. And finally, it is the D node. Select the tree as it is. How is the tree which we have selected? This is the tree which we have selected as it is. I am not doing any change. This direction is a downward. This is the branch number 2. This is downward again branch number 3. This is downward again branch number 6. This 2, 3, 6 is our tree. Now in this case, put only one co-tree branch at a time. If it is a tree, means 1, 2, 3, means branch number 1, branch number 5, and branch number 4, 1, 4, 5, these are the co-tree branches. Put one co-tree branch at a time. If I am putting this co-tree branch here, which is that branch? That branch is the branch number 1. That branch is the branch number 1. If we are putting that co-tree branch, which is the branch number 1 in this particular case, just give me a minute, I will be back. Yeah. So here, if we are putting this branch number 1, in that case, there is a formation of the loop. Now, how will be this loop current? This loop current will be same as the direction of this co-tree branch. This is clockwise will be its direction, and this is tie set number 1, that is T1, which is branch number 1, branch number 2, and branch number 3 is our first tie set. Branch number 1, branch number 2, and branch number 3 is our first tie set. Then I will prepare the tie set number 2. How many tie set we will have? The number of tie sets is equal to number of co-tree branches. How is the definition for the co-tree branches? Number of branches minus total number of the branches minus number of tree branches. Total number of the branches are 6. How many tree branches? We have the tree branches as a 3. Means here in this particular case, the number of tie sets in this particular case is equal to total number of the branches are 6 minus 3 branches are 3, which is equal to 3. This we will have 3 tie sets. Is it right? Then I will draw the tree again as it is. I will draw the tree as it is. This is the branch number 1, 2, and 3, and so on for that particular tree. This is A node, this is B node, this is C node, and this is D node. This is branch number 2, which is downward. This is the branch number 3, it is downward. This is the branch number 6, again it is downward. Now I will select a second co-tree branch. I have taken this, I will take this now. The next is I will put this branch. If I am putting this branch, how is the direction of this branch? Downward. That is the branch number 5. Means here, in this particular case, we will have this tie set as a tie set number 2. That is a T2. How is the tie set number 2? That is branch number 2, branch number 5, and branch number 6 forms the tie set number 2. That is T2. How is the direction of this tie set? Direction of the current of this tie set or this loop is clockwise, because in this case the direction of this current or direction of this co-tree branch is the same as that particular direction of that loop. Then I am starting with the third tie set, or it is the last tie set. This is tie set number 3. How is the tie set number 3? Look at, I will draw the tree as it is. This is one, second, this is third, and this is the fourth node. This is one branch, second branch, and this is the third branch, which is our selected tree. This is node A, this is node B, this is node C, and this is the node D. Its direction is downward. This is branch number 2. This is downward again, branch number 6. This is downward again, which is the branch number 3. This is our tree. Now already we have taken these 3 branches as a tree. We have taken tyset number 1 for this, tyset number 2 for this. This will be the tyset number 3. If we are taking here, this is the co-tree branch number 4th, and this is the branch number 4. Now this is the tyset number 3. How is the direction of this loop? The direction of this particular loop is very same as the direction of this branch. It is clockwise. This is clockwise. Is it right? And how is our tyset tree? T3 is nothing but the branch number 3, branch number 4, and branch number 6 is our tyset number 3. Is it right? It is the tyset number 3. Now if we have prepared from the given figure, we have prepared the oriented graph or directed graph. From this graph, we have selected one tree. From this tree, we have prepared the tysets. And here, we will prepare the tyset matrix. It is known as, its name is, B is a symbol, and this F stands for fundamental. This BF is the name of the fundamental tyset matrix. Is it right? How is this matrix? I am trying to draw this matrix here itself. This is the step number 3. What is the step number 3? Preparation of the matrix. Selection of tree, preparation. This is the step number 3. That is the preparation of the tysets. Preparation of tysets. And then step number 4 is preparation of the tyset matrix. Preparation of tyset matrix. Is it right? Tyset matrix. Now, what are the rows of this matrix and what are the columns? Rows of this matrix are tyset. This is tyset number 1. This is the tyset number 2, and this is the tyset number 3. These are the rows of the matrix. What are the column of this matrix? Branches. This is the branch number 1. How many branches we have? 6. Branch number 2. This is the branch number 3. This is the branch number 4. This is the branch number 5, and this is the branch number 6. If we have the 6 branches in this particular case, we will have 6 columns. We will have 6 columns. Now look at how will be the entries. Look at how will be the entries. I will prepare the entries in this particular case, and we will make those entries here. Just I'm preparing the matrix, and then I will write here. Okay, fine. I will start with the tyset number 1. I will start with the tyset number 1. Now look at how will be the entry for this branch number 1. For this branch number 1, its direction is the same as this loop current direction. That's why its entry will be +1. Its entry will be +1 is the entry for the branch number 1 in the tyset 1. Is it right? How is the entry for the branch number 2? It is same as this current. That's why again that entry is again +1. How is the entry for the branch number 3? For the branch number 3, again that entry is the same. That's why it is a +1, because this direction and this direction, both the directions are same. That's why its entry will be +1. And remaining branches are not the part of this particular loop. That's why those entries will be 0. That is the preparation of this fundamental matrix for this particular case. Okay, fine. Then I will come to the tyset number 2. How is the tyset number 2? In this particular case, this is the clockwise. This is the tyset number 2. Look at the branch number 2. This branch number 2, I will start with the branch number 1. Branch number 1, its entry will be 0 because branch number 1 is not the part of this particular loop. The next, for the branch number 2, its direction is downward and this loop current direction is upward. That's why its entry will be -1. -1 entry for the branch number 2. Branch number 3 is not the part of that particular tyset or that loop. That's why its entry will be 0. For the branch number 4, where is the branch number 4? This is 4. This is 4th branch. That is again not the part of that particular loop. That's why its entry will be 0. Branch number 5. This is the branch number 5. This is the branch number 5. Its direction is same as this loop current direction. That's why its entry is +1. That entry is the +1. And finally, this is the branch number 6. This is the branch number 6. This direction is downward and this loop current direction is upward in this branch. It is upward in this branch. That's why that entry is -1 is the entry for that particular case. And this is the tie set number. That is row number 2 in the tie set. That is fundamental tie set. Similarly, if we are going for the third row in this particular case, how are the entries? That is, I will come back to this tie set number 3rd. How is the third tie set? Entry for the branch number 1 is 0, because this branch number 1 is not the part of this particular loop. Then branch number 2, this is branch number 2, again it is not the part of loop, that's why its entry will be 0 again. Branch number 3, here is the branch number 3. Its direction is downward and this loop current direction is upward. Both are opposite to each other, that's why its entry is -1. For branch number 4, both entries or both directions are same, that's why its entry is +1. For branch number 5 is not the part of this particular loop, that's why its entry will be 0. And finally, for the branch number 6, its direction is same as this direction. Both directions are same. That's why its entry is +1. And this is the preparation of the tie set matrix.